This is the first part of a series of videos regarding quadratic functions. Quadratic functions are a big part of maths, and a lot of calculations are done on them, but it's quite a big section to discuss, so I've broken them down in a couple of videos. In this video, I'm going to discuss the three different models for quadratic functions, or three different forms, of quadratic functions. So you should understand all three forms, and you should understand what they do. So quadratic functions are functions, or they're called polynomials of degree 2. And this is a fancy way of saying the largest power of x is 2. So if you look at the function and you look at all the powers of x, the biggest power should be 2. So if you get y equals to 3x plus 2, you only have one x and it has a power of 1, so this is not a quadratic function. If you get 2x squared plus x, you'll have a power of 2, a power of 1, but the biggest power is 2, so it is a quadratic function. If you get something like 1 over x, let's do a negative power, so you have x to the power of negative 1 plus 3x cubed plus x. The biggest power right now is x to the power of 3, so it's not a quadratic function. So quadratic functions are is when the greatest power you have is raised to the power of, is that x is raised to the power of 2. So the three main forms of quadratic functions all have different properties. You can alternate between them as well. So the first one is the general form. And this is the main form that we use, and it's taught in school. So we have f of x is equal to ax squared plus bx plus c. Now, overall, any letters I'm going to use here are considered as just numbers. Any real numbers you could use. So a, b, and c are just any real numbers. But there is an extra condition that a can't be 0. Because if a was 0, then the x squared would disappear and you're left with a linear function and you don't have a quadratic function anymore. So, but b and c can be 0. So you can have something like f of x is equal to x squared or 3x squared. That is possible. So this is the general form, and I'm going to discuss some properties regarding the general form. But first, let me show the other one. So the other form is the factorized form. So factorized form. So you can expect to see brackets. So you're going to get the general form of it is, well, you have an a, and this a refers to this a actually. X minus k, x minus k, and then x minus l. So I'm going to do a curved L here. And again, this a, if I'm moving from this form to this form, the a will be the same. But the k and l are not b and c, so they're different numbers, but they do have a relation to each other. And in this case, again, we have that a, k, and l can be real numbers, but a can't be 0. K and l are allowed to be 0, that's fine. And the final form is the vector form. The vertex form. So it deals with something called the vertex of the graph, and I'm going to discuss what that is using an example from the book. So the vertex form is, the vertex form is f of x, and then you have x x minus h squared plus k. So it's a different form, and I'm going to discuss why h and k are specific. So they are selected specifically for a purpose, hence the name vertex form. Now all of these graphs have a property of have the same property, or they have the same graph, and from the graph you can deduce the same properties. So let me just, so a rough sketch of the quadratic graph would be something like this, for example. So you could have something like this, or you could have a downwards one. So let's just focus on this. So the first thing you notice is that I did two versions, and this is called the concavity. And you could either have a concave up, like this one, or a concave down. Or the graph is concaved upwards or concave downwards. So that's one, the concavity of the graph. Second property is the symmetry of the graph. And you notice that the graph will always cut in half. Obviously mine is a sketch, so it's not as accurate, but you'd get something that cuts the graph, let's say here, in half. So it's symmetrical, and all the values here will be symmetrical. So if I say, for example, this is 4, and this is 4, then they should have, obviously it's still a sketch, they should have the same y value. This would be 4, negative 4, that have the same y value. And the distance, this is really important, the distance from your points to the line of symmetry will always be equal. So this is a nice property to use throughout when you're answering questions. So, oops, sorry, it's the graph. So the symmetry is an important property. Then you also have a vertex. The vertex is the minimum or maximum point of your graph, and it could be a minimum like this one, or if it's a concave down, then you have a maximum here. And this is important when you're answering real-life questions. So if I say this is the model for the temperature, I want the lowest temperature, you're going to look at the vertex, not just any random point. You're going to look at this lowest point here, which not coincidentally lies on the same axis of symmetry. So wherever this symmetry line is, so we get an axis of symmetry. You'll get the vertex on top of that, so the minimum maximum point. And it depends on the concave, if it's concave upwards or downwards. The other property you're going to get is the X-Intercepts. The X-Intercepts are the lines that cross the X-axis, and you're either going to get none, 1, or 2. And that's it. Those are the three options you're going to get. And they could be, if you notice on this graph, it's this point and this point. Now, the X-intercept is something you should have seen before. And the way to find out with quadratics is slightly different, but you can find quicker ways to do it. The X-intercepts, it could be called X-intercept. It could be called the zeros of the function, because I'll explain why the zeros. It could be called the solution to, let's say your function is f of x, so it's the solution to this. Because notice that whatever x is, let's say the coordinate is, let's say k, the y coordinate will always be 0. This is L, your y coordinate will always be 0, so whatever your input is here, it has to be equal to 0. So this is what it means for the zeros of the function. It's although the solution to your function equals to 0, and it could be called the X-Intercept. So all these different properties, names, sorry. So these are the main properties you need to know from the graph. But again, if I'm talking about X-Intercept, I'm also talking about the Y-intercept. So the Y-intercept is when it crosses the Y-axis, and if I have a graph here, for example, and it does something like this, then this is my point of intersection. And Y-intercept, we've mentioned this before, we find it when x equals to 0. So you can just substitute f of 0 in your function, and you're going to be able to find the Y-intercept. There is a quicker method, but I'm going to mention it specifically for every property. So I'm going to use these 5 properties and discuss them with relation to these 3 forms. Now, just to note, if you want to move from one form to the other, you expand the vertex form, and you're going to get to the general form. Expand and simplify. Again, for factorized version, you expand and simplify, you'll always get to general form. To get from general form to factorized form, you'll have to use the roots of the function, or find the values of k and l, and then be able to factorize. To get to the vertex form, you'll have to find the coordinates of the vertex, and then you'll get to that. So we'll discuss this in a bit more detail in another video. So the first property is the concave property. And if A is positive, then it's a concave up. And therefore, if A is negative, then it's a concave down, and obviously A can't be 0, and it's the same thing here. Now, we don't have an A here, so there's no specific way of finding out how. Now, these 2 are the main forms I want you to focus on. This is a side thing, but it could show up. So the second property was the symmetry, the axis of symmetry. This is nice because you have a specific formula, and it's mentioned in your data booklet for IB Math Studies. So you have x equals to the axis of symmetry is a vertical line. Okay, so I'll call it AOS, is a vertical line. And vertical lines have a property of x equals to something. Now, you always need to write it as an equation, because it's an equation for the axis of symmetry. Equation, so it has to be x equals to something. Because it's a vertical line, you're describing a line, so it has to be x equals to something. So in this case, it's x equals to whatever your b value is. So if it's 3, you're going to put 3, and then so it's minus b, so whatever your b value is, divided by 2 times your a value. A could be 1, a could be 2, whatever, but this is the equation for the axis of symmetry. So let's say you have 3x squared minus 2, let's do 1, x squared minus 2x plus 3. What I recommend is from the beginning, define your value. So a is equal to, well, you're going to say 0, but actually a can't be 0, remember. The coefficient of x squared is 1. B here is negative 2, and c is 3. And so if I want the axis of symmetry, well, I know x is equal to negative p over 2a, and b is negative 2, so I'm going to put negative 2, and a is 1, so I'm just going to plug in 1. Now, negative times negative 2 is just 2. And then 2 times 1 is just 2, and so 1 is the answer. So if I have a graph, the axis of symmetry will be at x equals to 1, so it's going to be a vertical line that crosses 1. But it has to be in the form of x equals, obviously. So in this case, when you have the factorized form, the axis of symmetry is actually just k plus l over 2. Now, the reason is k and l are special points. I'm going to discuss them in a bit. And then I'm going to explain why the axis of symmetry is K plus L. You don't need to understand it, but keep in mind, this is definitely in your data booklet. I'm not sure about K plus L. The third property is the vertex. So the vertex of the graph is the minimum or maximum point. And the vertex, what I'm going to describe is the x coordinates. Now, you'll have to find the y coordinates, but the x coordinate is negative b over 2a. So it's actually the axis of symmetry, because as I mentioned, it lies on this line, so it fits this x value. Now, to find the y coordinates, you'll have to take whatever you got here and substitute it in the f of x. And so similarly here, the vertex x coordinates is x equals to negative b, sorry, not negative b, x equals to k plus L over 2. The fourth property is the X-Intercept. And for the, X-Intercept, for the general form, there's no specific, well, there is a specific formula to find it, and either you're going to see it or you've seen it, which is x equals to negative b plus minus square root of b squared minus 4ac over 2a. Now, for math studies, this is not in your data booklet, but for other subjects, it is included. For other roots of math and other curriculums, it might be included in your data booklets. For math studies, we don't use this to find the solution. What you could do is use other properties like factorization, I'm going to explain now, or you can just use your GDC calculator. And what you're going to do is you're going to go to your calculator. And if I just graph any quadratic function, so say x squared plus 2x. Okay, I'll just zoom in. Okay, you'll notice that the x-intercepts are, as I mentioned, where it crosses the x-axis. So you're going to go second calculate, and you're going to go to zeros. That's why I mentioned that the intercepts are called zeros. You're going to do left bound and right bound. So you're going to go to the left of your 0, and then you're going to slide down, go to the right of it, press enter, enter again, and you're going to get negative 2, 0. So your x-intercept is negative 2, 0. You're going to have to repeat it for the second one, so you're going to go here, and then upwards, enter again, and you're going to get 0, 0. So x-intercept, use the GDC, and for here, x-intercept is actually much easier because it's K and L. So your K and L, but notice you're going to take the other sign. So for example, if you had y equals to x minus 2, x plus 2, for example, which is a different number, x plus 3, your first intercept is x plus 2, and your second one is x negative 3. So these are your x-intercepts. So if you have negative 3, positive 2, your graph is going to look like this. So overall, if you found the roots, if let's say we are here, and you found x equals to negative 3 as the root and x equals to 2 as the root. So if you want to get to the factorized form, you're going to say, well, this is x plus 3 and x minus 2. So that's how you get back to the factorized form. And the thing about axis of symmetry, so as I mentioned, because these x values have the same y value, it means they're the same distance from the center. And so the axis of symmetry is right at the center of these two roots. So if I want the middle of these two numbers, I'm always going to add them and then divide by 2, which is why the axis of symmetry is adding the two roots and dividing by 2. Now we have the last property, which is the y-intercept. The y-intercept for the factorized form isn't clear. You'll have to just substitute x equals to 0. For this is actually easy because the y-intercept is just, obviously x will be 0, and then it's just the c value. So c could be 0, could be 5, could be 10, negative 2, up to the graph. So the curve intersects the y-axis at 0, c. So that's the main property. Now the vertex form is, there aren't many properties you can come up with the vertex form, but the main thing is that if you found the vertex, then you can write it in this way. And we use the vertex form because it's easier to solve functions using that form. So for example, if your vertex was 3, 2, for example, this would usually be h, this would usually be k, and so when you're graphing it, you're going to get when you're writing it, you're going to write x minus 3 plus 2. If I give you a vertex, if they give you a quadratic, now you can expand it and then find the vertex in a longer way. Just look at the marks for the question. If I give you x plus 2 plus 4, just remember that the positive value here is that the h is always negated. So if it was positive, it's going to be negative. If it was negative, it's going to be positive. So actually, the h is a negative 2 and k is 4. And so your vertex coordinate is negative 2, 4. And the way I know it's a quadratic function is because this is squared and then there's no other greater power of x outside. And so if I expand this bracket, if I go x plus 2 plus 4, expand it, I'm going to get the vertex form as necessary. You're going to get back to the general form, and then you could try and find it using the vertex form. So vertex form is not used as often, but it is useful just in case they give it to you. If you're more comfortable with working with general form, you can always expand it. Now, this was a long video, but hopefully it was clear in terms of the properties. So we've graphed it, we've done the different forms, a couple of examples in there. You can try and practice if you have questions. I would recommend using websites such as GeoGebra or Desmos. I'm going to put a link to one of my GeoGebra sliders where you can manipulate the A, B, and C values to test what happens to the graph. Be aware of functions, for example, where you have something like y equals x minus 4. Again, if this is something unusual for you, you can always expand it to get to the general form. But this is actually in factorized form, and the roots of this function is x equals to 0, and it comes from here, and x equals to 4, so it comes from here. If at some point there is a video on my channel explaining how to find the roots in more detail, you can try that, but at the moment this is for math studies, you would use the GDC calculator for it. This was just a side example, just to clarify a few parts. So these are the main properties, and try different things with these questions. So how can you find the equation of the line if you're only given the equation of the function if you're only given the graph, and so on, these details.